Are we live? We're live, yes. All right, so this is going to be, do you want the light on or off here?
Either one. One of the people in the back. No light on.
Lights off?
No.
Don't leave it on.
Lights on. And can we not use a red marker?
B6.
Yeah. All right, we are going to do section 3.6 today.
What were you also?
All right, 3.6, and maybe I should say graphing rational functions. Okay, so that's what we're going to cover today. Now, let me just say here, this is going to be a tough section. I'm only saying that to get your attention, hopefully, but apparently it doesn't work with some people. Okay? Rational has the word ratio in it, right? Which means, guess what we're going to use? We're going to do the F word today, fractions. I know you guys love the F word, right?
My wife checked the camera. It looks really fun.
It's really foggy, and I don't know why. It's usually because the lights are on.
We can put the lights on.
There we go. Is that better? It does seem to focus a little better with the lights off, but all right. Okay, so we're going to talk about rational functions, which are fractions. Okay, so I think I'm going to give you some good rules that are going to help you. Okay, number one, vertical asymptotes are found by looking at the zeros in the denominator. Okay, so anywhere the denominator can turn 0, you're going to have a vertical asymptote. Okay, then we're going to talk about horizontal, oblique, maybe I'll just say, etc. asymptotes. Okay? And the idea here is, number one, or maybe I'll say A, look at degree of the numerator. B, look at degree of denominator. Okay? C, simplify this fraction. Okay? D says if the degree of the numerator is less than degree of denominator, then you're going to have a horizontal asymptote. I'm going to abbreviate that HA, horizontal asymptote at y equals 0. E, if degree of the numerator equals degree of the denominator, then simplified fraction is the asymptote. And it could be slanted, or it even could be a parabolic asymptote. Now, the book doesn't like to talk about parabolic asymptotes, but I kind of do because I think it's helpful. Okay? Actually, you know what? I'm going to change this one to be greater than or equal to. And then I don't have to write a third one. Okay? I think that's good. Oh, actually, No, I do want to add one more. Can you see this? F. See if graph crosses horizontal or oblique asymptote by setting function equal to part E. Okay? So did you know that you can actually cross an asymptote occasionally? Okay? Let me make a note here. Can never cross a vertical asymptote. But you can cross a horizontal one or an oblique one. Oblique line just means a slant asymptote. Okay? Does that make sense so far? Clear as mud? Let's do some examples, and these are the rules that we're going to follow with this. Okay? So let's just start with a nice, easy one. Then you guys are like, oh, pick me, pick me. F of x equals 1 over x. Hunter, you got lucky, you got the easy one. You got the first question. First questions are always the easiest. You know what that looks like? No. You got the easy one too. And you're supposed to remember that from like 2 tests ago, 2 weeks ago. Want to look it up really quick?
That's why
I just need to graph it.
I just want, yeah, what does the graph look like?
it's like that.
Okay. All right, it's like that and that. Okay. Now, okay, let's go through our steps here. If you don't know, this one should be the easiest one. Vertical asymptotes are found by looking at the zeros in the denominator. Where do you get a 0 in the denominator? When x equals 0. So I've got an asymptote right here on the axis, right? Okay. Now the question is, so that one's done. That one ain't going to be crossed no matter what. Okay. So that's the easy one. The second one, you've got a lot more steps here to follow. Okay. Now you've got a horizontal or an oblique asymptote. We're going to talk about those. Look at the degree of the numerator. What's the degree of the numerator? No, it's not 1.
0.
It's 0. This is 1x to the 0 power, right? What's the degree of the denominator?
1.
1. Okay? So the degree of the numerator, so as you can see here, this one makes a lot of sense. I'm going to ignore that for an instance, but we're going to keep using that thing, okay? As x gets really big, what happens to the entire fraction? It's very close to 0, correct? Okay. And so if you take the limit as x goes to infinity, you're going to get very close to 0. Okay?
That was because you looked at the degrees.
Well, it was because I looked at the degree. We'll be doing that in a minute. But yeah, in this case, we're going to try to keep this simple, right? As x gets really big, I'm going to get very close to 0. Okay? And now, hopefully you know that this graph looks like this. Okay? Hunter, you're going to get this problem right on the next test, though, right? Because you're really disappointed. Okay? All right, so this is your basic
Which rule?
rational function.
The limit?
Which rule? Look at the degree of the numerator. So we can follow these rules on here. I thought this one you didn't need to really follow them that closely because it just made sense. But degree of the numerator is 0. It's x to the 0 power, right?
Yeah.
Which is 1. Degree of the denominator is 1. So I've got 0 over 1. We're going to simplify this fraction. It's already simplified. Okay. If the degree of the numerator is less than the degree of the denominator, you're going to have a horizontal asymptote at y equals 0, which we do. Okay? If So this one doesn't apply. See if the graph, here we'll do this one anyway, we don't need to, okay? See if the graph crosses the horizontal. This one could be crossed theoretically. Doesn't mean it will be, but here's how we would see if this is going to be crossed, okay? So in part E here, I've got a horizontal asymptote at 0. So I'm going to set 1 over x equal to 0. I want to see if that's a solvable equation. Sometimes it will be, often it will not be, okay? If I were to solve this equation, what would I do next? Multiply both sides by x. So that goes away, and I get 1 equals 0. Is that ever a true statement? Only if I owe you money, right? Okay? All right, so that's not, so therefore, because this is a false statement, it does not cross. Does not cross. Okay? So that's how we've used all of those rules on a nice simple one.
Why would that help us to know if it crosses the horizontal or oblique asymptote?
Because if it did, then I would have to figure out where it crossed, and I would cross it.
Wouldn't that just be a 0?
Wouldn't it be a 0?
Where it crossed it would.
Well, I might not have it on, what if my asymptote's up here?
Oh, okay.
So it wouldn't necessarily be a 0.
Got it.
Okay? All right, so now let's do another one here. Let's do, they like to use R of x for rational function. R of x equals 2 over x minus 3. Okay? Now, because this is basically of the same shape as this graph is going to look like this graph shifted. Okay? So, where is it going to be shifted? Let's pick on Jackson. Okay? Any ideas?
My guess is down 3, or I don't know, right 3.
Yeah, it's one of those two. Which one?
Would you use the rules to figure
We
it out?
probably ought to use these rules to figure it out. Okay, vertical asymptotes, we're always going to find those first.
Okay.
Vertical asymptotes are found by looking at the zeros in the denominator.
So
So what turns the denominator 0?
positive 3.
Positive 3. So x, if I were to ask you the domain, x cannot equal positive 3, right? Okay, so I've just found my vertical asymptote, 1, 2, 3.
Shifted it right.
It shifts it right 3. Okay, so we know that. Now we need to find our horizontal or oblique, and I put etc. because you still might find a parabolic asymptote. Wouldn't that be fun? We're going to find one later today. Okay, so what's the degree of the numerator here?
0.
The degree of the numerator is 0. The degree of the denominator is 1. Okay. Now, another way to think about that is to simplify this fraction. Okay. So if I'm going to ignore this minus 3 for a minute because it doesn't matter. I'm only looking at the leading terms here. Okay. So this simplifies to 2 over x. As x gets really close, as x gets really big, what happens to this whole fraction?
Closer to 0.
It goes closer to 0. So this one does not change here. Okay? All right, so I've got that here. Now, so I simplified the fraction, I got 2 over x. If the degree of the numerator is less than the degree of the denominator, I have a horizontal asymptote at y equals 0. If the degree, so this one doesn't apply, see if the graph crosses. Do you think that it's going to cross that asymptote?
No.
No, because
Set it equal to
I'm going to set this equal to 0, because I set it equal to this asymptote. Okay.
2 to 0.
Multiply both sides by x. Does 2 equal 0?
Nope.
Only if, I owe you money, right? Okay, so it does not cross, does not cross. Okay, so now I can just follow the same basic shape here. Is that an easy point to find? You can probably figure out where that point is, right? Okay, how do I figure out what that point is? X is 0. So then y is, so this point is at 0, negative 2/3, right? So that one was pretty easy to find. Correct? Okay. All right, let's keep going. I'm going to keep the rules here because I think we want to refer to them often. So I'm going to erase this problem here. Okay. How about, let's do S of x equals 3x plus 5 over x plus 2. Okay? All right, so now let's pick on Christian. I think it's your turn. Okay, rational function, right?
Yeah.
How do we know? Well, how do you know this is a rational function? How do you know it's not a polynomial function? Because it's got a fraction, okay? All right, first step, we find our vertical asymptotes. Where does the denominator turn that 0?
Is that when you said the bottom equals 0?
It's always the denominator is the bottom, right?
Right, so x plus 2 is equal to 0, so x is equal to negative 2.
X cannot equal negative 2. 1, 2. Okay, so I clearly know I've got a vertical asymptote there. Now let's talk about horizontal, oblique, etc. asymptotes. Look at the degree of the denominator. The degree of the degree of the numerator is 1. Degree of the denominator 1. So they're equal. Okay, so this part D does not apply. If the degree of the numerator is greater than or equal to the degree of the denominator, then we use the simplified fraction. So at this point, all I care about is the leading terms. Okay? The simplified fraction is going to be y equals 3x divided by x, and that simplifies to 3. Y equals 3. That's where my asymptote is. Okay? So I've got a horizontal asymptote at 1, 2, 3. Okay? Now we have to ask the question, does it cross? Okay? So I won't make Christian do all of this. We'll pick on Julia. Right there. You related to Andrea? I know she had the same last name. Huh?
What?
Are you related to him?
No.
Okay. Just lucky to have the same last name.
Oh, yes.
Okay? I wouldn't claim it either. All right, so we're going to use, so we need to decide if it crosses this. So how do we decide that?
Set
Set something equal to,
0.
no, not 0. Where's my asymptote? My asymptote is not at 0 anymore. Where's that? My horizontal asymptote is at 3. So we're going to set it equal to 3. What are we setting equal to 3? The original function. 3x plus 5 over x minus 2. Or was it a plus 2? I think it's a plus 2. All right, cross it out. Looks like a minus. All right, can we solve that equation? How do you solve that equation?
Multiply
Multiply by x plus 2. X plus 2. So this becomes
3x plus 6.
3x plus 5. If I subtract the 3 x's, they both go away, and I get 5 equals 6. Is that a true statement? It's a false statement, so therefore does it cross? No, it does not cross. Okay. So now the question is, what happens next? Okay? And I guess at this point, maybe I should add a step number 3. I didn't need it till now. Pick a point in each vertical region. Okay? Now, it might be interesting to see if it has intercepts. So I'd probably want to pick intercepts, either the x-intercept or the y-intercept. Which one would you like to pick, Julia? I'll let you pick, Julia.
What?
I'll let you pick, and I'll make somebody else do the problem. You want to pick the x or the y?
The X.
X, and we're going to pick Ethan. He wants to do it, I can tell. If you said the x is equal to 0, what's left? 5 over -2, right? Or +2? +2, sorry. I shouldn't draw a box through my plus sign. Okay, so if I get a 0 here, I'm going to be at 5/2. So 0 and 2.5 right there. Okay? So we already know that this doesn't cross, and it's going to go down here. We probably ought to figure out where it's going to cross here. How would we find that, Ethan? Set y equal to 0 and solve. So 0 equals 3x plus 5 over x plus 2. How do you solve that? What'd you say?
Still asking me?
Uh-huh.
So multiply by x plus 2.
Multiplied by x plus 2.
0 by 5 by 2.
So 0 equals 3x plus 5.
Subtract 5.
Subtract 5. 3x equals -5. Divided by 3. X equals -5/3, which is more than 1, so I'm going to draw it right there. Okay? All right, now, so we know what happens in this region. Now we've got to figure out what happens here. Is it on this side or is it on this side?
Yes.
Why is it on the top side?
Because power function. So it's still 1 over x.
So I've only got one intercept, right? And I already found it. If it were on this side, it would have to cross here, but clearly it doesn't cross. So it's got to be here. Now, if you're not sure, how do you prove that? Pick a number on this side, such as what? -4. I would have picked -3, but it doesn't matter. S of -4 equals what? 4 times, sorry, plugging it into here. S of -4 is 3 times -4 plus 5 over -4 plus 2. 3 times -4 is 12 plus 5.
Is
-7. -4 plus 2. -2. Those cancel, and I get a positive number. That's at 7/2, which is about 3.5, which 3.5 is above the line. Guess I should have drawn it closer to here. It's going to look like that, okay? And we know it doesn't cross, so we're good. Okay, does that make sense? Okay. You good, Caitlin?
Just a little confused.
A little confused? What are you confused about?
I don't know, it's just the horizontal. I don't know, I'm just trying to follow along,
Okay,
but
you want to do the next one?
yeah, let's do another one.
Okay, let's do another one. All right, how about by the way, we haven't really stated our domain and range. Before we go on to the next one, what's the domain and the range? Mallory, it looks like you want to do that.
The domain cannot be equal to -2.
What is not equal to -2?
X.
X, don't forget that. Okay, your range?
Is that just setting it equal to 0 for y? Is it
Look at
negative?
your range. What are all the possible y values you can pick?
Y is greater than or equal to -infinity and less than. It's just,
There's only
Y
one
is-
value that I can't pick for y. Just like there's only one value I can't pick for x. X cannot be -2. Y cannot be,
what was that? 3?
y cannot be 3. That's your domain and your range. That was easy, right? Okay,
Is 1 over x not a power function?
this is not a power function
Because, okay,
because it's irrational. Power functions only apply to polynomials.
got it.
Okay? All right, so you ready for a good one, Caitlin?
Yeah, let's do
All
it.
right, let's do it. Okay, I'm gonna erase this because I don't want to move my camera, I don't want to erase the rules. Oh, except for I already erased rule 3. Here, I'll write it again. Rule number 3, pick a point in each vertical region to graph it. Okay? All right, so now let's do another one. Here we go. R of x equals 2x squared minus 4x plus 5 over x squared minus 2x plus 1. Okay? So, what kind of a function is this? Scary function. Good, right in time for Halloween, right?
That's really scary.
What'd you say?
That's really scary.
This is a scary function, but that's not what we call it in math. We call it a,
Not parabolic, but polynomial. So,
no, this is not a polynomial function.
That's factorable, right?
What kind of a function is it?
rational.
Rational
Okay.
function, that has polynomials in it, but it's a rational function, okay? It's rational because even though it has polynomials in it, it's a fraction, right?
Oh,
It's a ratio.
There we go.
A ratio or a fraction, okay? All right, so let's find our vertical asymptotes. How do we find those?
You wanted me to tell you?
Uh-huh.
Oh, sorry.
I thought you were volunteering
I was writing
for
it down. Okay. So for the vertical, you have to find out when what x can't equal because it's on the bottom.
Correct.
You set it equal to 0.
So x squared minus 2x plus 1 cannot equal 0.
Yeah.
That's fair.
So then that's -1.
Nope,
Or do you want me to factor it?
I want you to factor it.
Okay.
Because you guys are all really awesome at factoring now.
Okay, so you have x in both of the parentheses, and then it would be -1 on both.
Cannot equal 0. Okay. So therefore, x cannot equal,
It can equal +1, and that's a multiplicity of 2, right?
well, we don't care about multiplicities, we're talking about asymptotes.
Okay.
But I guess, yes, your asymptote has a multiplicity of 1. But it's vertical, so I ain't gonna cross it anyway, it doesn't matter.
Okay.
Okay? Verticals will never be crossed under any circumstances. Okay? Do you want to keep going or do you want to tag somebody?
I kind of want to keep going.
Okay.
I just get confused with the horizontal, so
All
I
right.
don't want to try it.
We'll keep going then.
Okay, so
Horizontal oblique. Look at the degree of the numerator.
that's 2.
2. Degree of the denominator,
Is 2.
also 2. So we're going to simplify this fraction here. Okay. So y equals 2x squared over x squared. If I simplify that, Those cancel,
Y
correct?
equals 2.
So my range, y cannot equal 2. Okay, so I've got 1, 2. Now I have a horizontal asymptote there.
Okay.
Okay,
Yeah, I was.
so I kind of went through those 2 steps super fast.
So,
The degree of the numerator is not less than, so that doesn't apply.
So,
If it's greater than or equal to, we use the simplified fraction, which I just did here. Okay, we just ignore all these terms. Because as x gets big, these terms don't matter as much as the first terms. Okay, that's why. Yes.
So if we have a question where either the numerator or denominator in factored form, we'll need to multiply it out in order to get to that fraction, right?
Yeah, if it's already factored, that's nice for your vertical asymptotes, but you really just need to check the degree. And all I really care about is the first terms. I don't have to do the whole thing. Okay? All right, so now we need to decide if it crosses. Jackson.
your range is y cannot equal 2, right?
Y cannot equal 2. Thank you. That's, I said it, but I forgot to put the slash through it. Yes.
Just to confirm, so the reason that we got the first part is because both degrees are equal. If the top one was even greater, then it would still be that case, but if the bottom one was like x cubed, then we would just set the whole thing to equal to 0.
So if this was 2x squared over x cubed, is that what you're asking?
Yeah,
Then the x squared cancels that and I'm left with an x, right? That becomes 2 over x. As x gets really big, what does that approach? 0, so that would be on the axis.
oh, okay, so if there is a variance, then it will be 0.
If, yeah, so that would be the numerator less than the denominator. So that would be this one. So
Okay,
therefore it would be 0.
Oh, yeah, because this was, I thought it was like, if there's a discrepancy where it's bigger on the bottom, then you set it equal to 0, but okay, that's way
Okay.
easier.
Okay. Yeah, these rules, I can't remember if they were in this book. I don't think they were written very well. That's why I put them there. Anyway, they are kind of written in there. All right, so do you want to keep going, Caitlin, or are you ready to tag somebody?
We can tag somebody.
Want to tag somebody? Okay, so Bailey, the question is, does it cross?
So we're trying to figure out if it crosses.
We're trying to figure out if it crosses the horizontal or the oblique asymptote. One of these days, we're going to get an oblique.
I know, Suzanne, like, not
I'm glad that you got picked before that came, right?
so that,
Okay, so does it cross? How do we figure that out?
so.
Okay, so to see if it crosses, set the function equal to part E. What's part E? That would be this part here, y equals 2. So we're actually going to set it equal to 2 this time, not equal. So 2 equals what? The original function. 2x squared minus 4x plus 5 over x squared minus 2x plus 1.
So then when we take, I don't know if this is more difficult, but when we take the bottom, when we take the denominator.
Okay, we're going to multiply by the denominator. Anyway, that's going to go away, and I'm going to multiply this by x squared minus 2x plus 1. Okay, so now we're going to FOIL this out. We're going to get 2x squared
Oh, yeah. Squared
minus
4x plus 2.
plus 2 equals
Just 2x squared minus 4x plus 5.
plus 5. Okay, so the 2x squareds will cancel each other. The 4x's will cancel each other. I'm left with 2 equals 5.
So they don't cross.
It does not cross. Does not cross. Okay, so it doesn't cross, so that's good to know. Now, the idea here is we need to pick a point in each vertical region. So point here, point here. I'd probably want to see if there are any intercepts. So what would be the easiest point to pick right off the bat? If I set x equal to 0, this all drops out, right? And I'm left with 5. So at x equals 0, y equals 1, 2, 3, 4, 5. So I know that point. So clearly, this doesn't cross anything. It's going to go something like this. Correct? Okay, so what's another point that I should pick? Something in this region, right? Now, if it's in this region, it's probably going to cross here, right? So we probably ought to figure out where that is. Here, here, somewhere along there. How do I find that point? Plug 0 in for y. So I'm going to say 0 equals 2x squared minus 4x plus 5 all over x squared minus 2x plus 1. Multiply both sides by the denominator, correct? So that's just going to go away. Okay, and then what? Is that factorable? It's not factorable, is it? So that's not going to be a very nice point. We can use the quadratic formula. I don't think I care that much. Okay? But what we are going to say is, I mean, it's going to cross, and it's got to cross in this area, right? So I'm just going to go there.
So,
it's going to be good
so we
enough.
don't have to find points?
If they're easy to find, you should find them. That one's going to be like, I don't care on that one. If you need the quadratic formula, don't worry about finding it. Okay? How's that?
Okay.
But you should be able to recognize that this isn't factorable. Okay? If it is factorable, find it. Yes?
So are we finding those points so that way we know which side of the asymptotes they go on?
Yeah.
Okay, because like if we would have had a different one, it could have been below the asymptote on the left-hand side, right? Okay.
Good. Okay? These are fun, huh? Can't wait to do this homework tonight. All right. Oh, you know what? I made a mistake. Maybe we should have found that thing. Let's do that again. Okay, quadratic formula. How do we find that? So negative b becomes positive 4 plus or minus the square root of 4 squared minus 4 times 2 times 5, correct? All over 2 times 2, okay? This becomes 4 plus or minus the square root of 16. 20 times 4 is 80, all over 4. That's an imaginary number. I was guessing that it was here. That was a wrong guess. Because that's an imaginary number, it's got to be up there. Guess you should find it anyway.
Okay.
And you'll save yourself from a mistake and go, yeah, so there are no x-intercepts on this. Okay? Now, the easier thing to do is just to pick, say, f of 2, or r of 2, and solve it. And then you would have seen that it's above the asymptote. That's another way to solve it.
What was
Okay?
the way that we did it? We
We tried to find the x-intercept.
We tried to find the x-intercept. I got an imaginary number.
got it.
Okay? Because it's imaginary, it's got to be above the line. Okay? These are fun. All right. Let's see, did we find the domain and the range?
Yeah, earlier.
Hunter, what's the domain and the range? I'm going to pick on you again. Make sure you're paying attention.
Domain is all the numbers.
Nope.
Oh wait, it's x can equal 2.
X can equal 2?
Yeah.
X can equal 2. When x equals 2, it's right there.
Oh,
So that's 2.
x can equal 1.
X cannot, that's the domain or the range? Nope,
Wait.
that's the domain. X cannot equal 1.
And then y can equal 2.
Y cannot equal 2. Don't mix up your domain and range, okay? All right. How about can I erase that? Yep. Or should I erase the rules? Just do you want the rules?
You can get everything. Because of the shape of the graph, wouldn't the range be y cannot be less than or equal to 2?
Gosh. Yeah, that would actually be better, right? Y has to be greater than or equal to 2. Because there ain't nothing down here, right? Very good, Cameron.
But it can't.
Put the star on
It
your
can equal
forehead.
2? I thought it can't be 2.
Well, it can't be 2, right? Don't put an equal on that. Y greater than 2. Okay? You guys are on your game today. That's good. Don't let me be leading you astray. Okay? All right. Okay, how about r of x equals 3x squared minus 2x minus 1 over 2x squared plus 3x minus 2. Andrew, it must be your turn. Now that you're awake. What do you think?
Factor.
Factor what?
Remainder. The denominator.
The denominator. Is the denominator factorable?
Yes.
Yes. 2x and x, right?
Yep.
1 and 2. Okay, what are my signs?
Plus 2 and negative 1.
So that's positive 4 minus 1 is 3. Negative times a positive is a negative. Perfect. Okay, so you've got a vertical asymptotes at where? Where those equal 0?
Negative 2 and 1/2.
1/2. Okay. All right. So let's put those on our graph here. 1, 2, 1. Okay. All right. You want to keep going, or you want to tag somebody? Tag Cameron. Cameron, you can punch Andrew later. Okay.
Yeah.
Just do it outside of class. Okay, so step number 2, we're looking for horizontal or oblique asymptotes. What's the degree of the numerator?
2.
2. Degree of the denominator is also 2. So I want to simplify this fraction here. Okay, horizontal asymptote. So this becomes y equals 3x squared over 2x squared, correct? X squareds cancel, and I'm left with
1.5.
1.5, okay? So 1, 2, 1.5 is about right there. Okay? All right, so I've got my horizontal there. Okay, so see if the graph crosses the oblique asymptote. How do you do that?
Wouldn't you set the denominator equal to 0?
Nope, not to 0.
Or equal
Part
to the 3/2.
3/2 that we just found has to equal what?
the whole equation.
The original function here. 3x squared minus 2x minus 1 over 2x squared plus 3x minus 2. How do I solve that?
Multiply the
Yeah, let's cross multiply, okay? So multiply this by 2x squared plus 3x minus 2. That's going to go away. And 2x squared plus 3x minus 2. I'm going to multiply both sides by 2 to get rid of this, okay? So 3 times this is
6x
6x squared
squared. 9x squared.
9x
Negative 6.
and 6 equals
Wait, no, that's 3. 6x squared.
6x squared
Negative 6x.
minus
Or,
4x
Yeah, 4x. And then negative 2.
minus 2. Okay? The 6x squareds cancel each other, right? Now what?
Add the 2 to both sides. Take away that 2.
We add the 2. It's a terrible looking 2. Add the 2, that goes away. I'm going to subtract 9x while I'm at it, right?
Right.
So I've got negative 6 plus 2.
That'll be negative 4.
Negative 4 equals negative 4 minus 9.
Negative 13.
Negative 13x.
Well, and then 13 divided by 4, right?
Divided by 13. So x equals negative 4/13. Okay, so what did I just do?
This is positive.
Positive 4/13. What did I just do? Got lost, right? What were we checking? We were trying to see if it crossed. Does it cross? Yes, it does. I got an answer here. So it's going to cross this asymptote. Y equals 3/2. X equals 4/13.
So that's the point it crosses.
That's the point it crosses at. Okay. So in this case, it crosses 4/13. That's about 1/4, right? And 3/2. So 1/4 and 3/2, about right there. So that one actually crosses. Yes.
Can we go back to how you got rid of 3/2, how you got rid of the 2 on the bottom?
So I multiplied both sides by 2.
Oh, okay.
Okay. So this is a weird one that actually crosses. Okay. Now, good points to find are intercepts, right? If I set x equal to 0, what am I left with?
Positive
1/2. So when x is 0, y is 1/2. Okay? When y is 0, I'm going to set this equal to 0, right? 0 equals, and it's just going to be the numerator because the denominator is going to go away, right? 3x squared minus 2x minus 1. Can you factor that?
Yeah, you take 2x.
Okay. Factors into 3x, x, 1, 1. Get my signs right.
Positive. Both one would be positive, one would
That's minus one to positive, right? So it crosses at x equals negative 1/3 and x equals 1. Do you see that? So x equals 1, okay? So that's 1, and x equals minus 1/3, and that's another one. Okay? So the nice thing about this is, okay, we've got 3 points here, right? These are all going to go up like this, and this is going to go down like this, okay? This is the 1 point in this region. Doesn't cross. So now we have to decide what happens in this region. Kelly, it must be your turn. What happens in this region?
I'm assuming it's going to be in the top left, just based on all the other functions, but you can also pick a point that's less than -2.
Yeah, if you're not sure, pick a point, like -3, right? But yes, it's going to be here. How do I know it's going to be here and not down here?
Based on the original 1/x.
I've already found all the intercepts. There's only 2 of them, and I found them both. So it's not going to intercept here. Okay? All right.
And then for the middle one, you just know that it looks like that, because that's how
Well,
it normally,
I've plotted these 3 points, right?
yeah.
It's not going to go back up, is it? It's not going to cross here
Yeah, it
again.
crosses it.
So it's going to have to go down this way.
Okay.
And here we've already crossed it, so it's not going to recross back over the y. Okay? These are fun, aren't they? We haven't even gotten to a crooked asymptote yet. And just like, oh man, I don't know if I can stay away from that. All right, but aren't you glad we finally found where it crosses? About time. All right, what's the domain and the range on this? Jonathan, it must be your turn.
So it's a x cannot equal -2 or -1/2. Positive 1/2.
-2 or positive 1/2.
And then y not positive 1/2.
Yeah, okay, right there.
Oh, yeah. So y is all
Y is the element of all real numbers. That one's kind of weird. Who knew? Even though I've got an asymptote, isn't that weird?
For visual representation, could you just erase the middle asymptote, or is that so technically? Because for that specific domain, I guess, there is no asymptote because it does cross.
Oh, yeah, I guess, yeah, you're saying, could I erase the asymptote here? Yeah, I guess technically you could. Normally we don't,
But like mathematically, that's what it.
but yeah, mathematically the asymptote only applies in this region and that region. It doesn't apply in the region. Right. That's good.
So it's
Very good. Good job, Angel.
I get it now. That makes more sense.
Okay?
Can you explain the difference between asymptote and oblique, or are they the same?
Oblique is crooked.
Okay, like why?
We'll do one of those.
Okay.
I just know this is so much fun that we're gonna do like 500 of them. I do know that this is where people are gonna get screwed up, so I do want to do a lot of examples. Okay, sorry, I'm erasing that. Is it too late? Okay, let's do another one. You know what I forgot to mention? I just remembered. I wonder if they have any examples in here. They do have an example in here. I'm deciding if I should give you another rule or wait for the example. I think I'll wait for the example. All right, let's see how good you guys are. Okay, so whose turn is it? It must be Mallory's turn. Put her sweater on, she's getting ready to leave, but good thing I picked on her. Okay, so what do you think?
We have to find the vertical asymptote.
Vertical asymptotes first.
set the denominator to 0.
Okay, how do we do that?
0,
Let's factor it first.
okay.
Factors of x squared,
X squared.
x and x, right?
Oh, yeah.
Factors of 2,
Negative 1.
2 and 1. You said it was negative 2 and positive 1. That gives me negative 2 plus 1 is negative x. So I think you get your signs backwards. Positive 2 and negative 1, right? Positive 2 minus 1 is 1. Positive times a negative is a negative. Okay? So my vertical asymptotes are where?
2 and negative 1.
X cannot equal negative 2 and positive 1. Let's just draw those right off the bat. Negative 2, positive 1. Okay? All right, now what?
And then you have to find the horizontal.
Horizontal oblique. What's the degree of the numerator?
2.
Degree of the denominator? Also 2. So we only care about these first terms here. Okay? So for my horizontal slash oblique, I'm going to get y equals 2x squared over x squared, correct? I'm going to cancel those, and I'm going to get y equals 2. Or really, y cannot equal 2, except for maybe it can. I guess maybe I shouldn't do that. 1, 2. Okay. All right, so we've done all that. We want to see if it crosses.
So set 2 equal to 0.
So we're going to set that 2 equal to 2x squared plus 7x minus 4 over x squared plus x minus 2. Okay.
And multiply the top by the bottom and then the 2.
Okay, so those go away. This becomes
2x squared
2x squared
plus 2x
plus 2x minus 4 equals 2x squared plus 7x minus 4.
So 2x squared cancels.
2x squareds cancel.
The negative 4 cancel.
The negative 4's cancel.
And then 2x equals 7.
2x equals 7x.
So it doesn't cross.
So minus 2x. 0 equals 5x. X equals 0. So does it cross? It crosses where? At 0 and 2. So at 0 and 2, it crosses again. What good is an asymptote if it crosses, right? What an asymptote. Okay, so now if we plug in 0, positive 2. So, oh, I actually just found that one. That didn't help. Except for we now know it's a legit one, right? Okay. When y equals 0, 0 equals, I'm just going to put it equal to the numerator because the denominator is going to go away anyway, right? Do you see why the denominator goes away? Okay. Now what? Just going to factor. What have I picked on? I think I picked on everybody who's white. Always makes me wonder why people come to class. There's lots of better places to sleep. Niels. What factor?
Let's try 2x and x.
2x, x.
And 2 and 2.
How about 1 and 4?
Yeah.
1 and 4.
Plus and minus, right? 2 times 4 is 8x, minus x is 7x, negative times positive is negative. Okay? So, x equals
Negative 4.
negative 4,
Positive 1/2.
positive 1/2. So x equals negative 4, 1, 2, 3, 4. We know that's working here. So we know clearly it goes something like that. And x equals 1/2. So that's going to be right here. So we now know what happened in the middle region.
Right, let's start starting on the top.
Okay. So what happens in this region?
Assuming we don't have any imaginary numbers, which should be the top right.
Well, we probably will have imaginary numbers right there, yeah. It does not have an intercept in there, so it's got to be there. Okay? You guys seem like you're catching on to this.
But what were you saying about a crooked asymptote?
I don't know. One of these days we'll get one.
Oh, that wasn't one?
That was one, that one still. Let's see, do you guys want a crooked one?
Yes. Oh, sorry, question.
I have a question.
Okay.
Question.
How do you know that it's over there in the top?
How do you know?
Yeah,
Because I found both intercepts and there's not an intercept over here.
okay, but. there's
And if you're not sure, what should we do?
Plug in 2.
Pick a number bigger than 1, right? So such as r of 2. So just plug it in, 2 times 2 squared plus 7 times 2 minus 4 over 2 squared plus 2 minus 2. 2 squared is 4 times 2 is 8 plus 14 minus 4 over 4 plus 2 is, those go away, 4, right? 22 minus 4 is 18 over 4, which is 4.5. So look at that, right where I drew it. So when x is 2, y is 1, 2, 3, 4.5. And I guess I should have drawn it over here. Now it's more accurate than it was. That make sense?
Yeah.
Okay. Mallory.
So I have 2 questions. So this one is, I don't even know if there's an answer to this, but there are like 3 arrows on there. How do you know how many arrows are going to be there? Are there always 3? Because like one that goes to the y-axis, there's one on the top corner, and there's one that goes to the x. Are there always 3?
Well, so the arrows signify that it gets really close to the asymptote, but it will never touch it.
Okay, so is that because of how many asymptotes there are?
Yeah, basically I've got this divided into 3 regions. So yeah, you're gonna have arrows. So yeah, these will get close to the asymptote, but they'll never touch.
And then my other
Except for right there, then it crosses.
Okay. And then my other question, when you're finding the horizontal, and you take just the leading factors of the original
Okay.
function,
Finding the
does that
horizontal,
ever change, or is it always the leading 2?
it's always the leading 2. Yeah. Okay? Do you know why that is? Because as x gets really big, these terms don't matter, only those terms matter. And so they're the ones that are going to be the ones that are going to affect your horizontal asymptotes. Okay? One of these days, we're going to get a crooked one.
Do you mind if I do domain and range on this one?
Yeah, domain and range. I keep forgetting to ask that. That's good. What's your domain and range?
Is that x cannot equal 1 or -2?
X cannot equal, is it 1? Yeah, no, it's
Or is it
1.
1/2?
Sorry, that's not the right place to look. It's right there.
Yeah, okay. So
X
1
cannot equal 1 or -2.
And then your range is all real numbers, right?
Range, yeah, because it crosses here. Normally it would be that, but yeah, all real, Y element of all real numbers.
Cool.
Or negative infinity. Yes.
So, is that pretty typical where you, in the middle it'll cross? If it did cross, would it just be like a parabola in the middle?
Kind of, yeah, a U shape, probably not parabola, but yeah. All right, can I erase it? Or should I erase the rules? Are you guys good with the rules? Huh? We can erase the rules?
Yeah.
Okay, you gotta remember it all now. All right. So let's do R of X. Oh, I'm off the board. Maybe I should move it over. No, let's use the whole board. Okay. R of X equals X squared minus 4 over 2X squared plus 2X. Okay. Spencer, I don't think I knew yet. You should be an old pro by now.
Yeah, we want to find the vertical asymptote. So
Okay.
we're going to look at the degrees of the first two elements, right?
The vertical?
That's
Vertical, we're just looking at the denominator.
Right, we're going to set y to 0.
Okay.
What if you can simplify that?
Can you factor that?
Yeah,
No,
you can take the
whole thing.
the 2 and the x out to get
We can take out a 2X and we're left with
x plus 1.
X plus 1.
But then on the top one, you get an x plus 1 and you could cancel those?
And at the top, you've got X plus 2.
Or
X
oh, it's
minus
2. My bad. Never mind.
Okay. It does bring up an interesting point, but I think we'll cover it. No, no problem. Okay, so therefore your vertical asymptotes are where?
It's going to be -1, and would it be 0 for the other one?
That's correct. Okay, let's start drawing our graph here. -1, 0. Okay. Next step,
No, the horizontal.
horizontal slash the oblique.
That. We plug in 0 for x, or we need to find.
What's your degree of the numerator?
So the degrees are 2 and 2.
So I only worry about these terms here, right? So y equals
It's going to be 1 over 2.
1 over 2, right? So 1/2. So if that's 1, that's 1/2. Okay? Now we're going to go back to his notes. Now we need to see if it crosses, correct?
Yeah.
How do we check that?
Okay. So to see if it crosses, we're going to plug in the y, so 1/2 equals
1/2 equals,
x over x to the second power minus 4 over 2x squared plus 2x. And then we're going to times it by 2x squared plus 2x. Both sides.
I want to get rid of this 2 as well.
So then multiply both sides by
2.
2.
So I'm left with
2x squared plus 2x equals 2x squared minus 8.
those cancel. 2x equals -8.
So divide by 2, we get x equals -4.
Okay, so what did I just find?
We just found where it crosses the
It crosses at x equals -4, y equals 1/2. So x equals -4, 1, 2, 3, 4. Y equals 1/2, so it crosses there. Okay?
Whoa.
So does that mean we're not going to have one in the middle this time?
Maybe, I don't know, let's see.
Then let's see if it crosses, if it has an x-intercept and a y-intercept.
Okay, if I set my x's to 0, I'm left with
You're -4.
-4. That's kind of weird.
Isn't it backwards for the -4 and 1/2? I think it's the -4 is the y value of that intercept?
I don't think so. Let me see, what did I do wrong here? I said it equal to 1/2, 2x squared plus 2x equals 2x squared minus 8. 2x, x equals minus 4. I write the problem down right. 2x squared minus 4, 2x squared plus 2x. Oh, yeah, you're right. I did screw that up. Y is -4. There we go. That's better. If I put x is 0, y is -4. 1, 2, 3, 4. But we got a problem because it's on the asymptote, and it never can cross the vertical asymptote. So that one's no good. Okay, so that's where it would, but it doesn't. Okay, because we cannot cross. Yeah, so you can't cross the vertical asymptote. Period.
So how come that worked out when you set it equals 0?
It does. So this is this here. If I put x is 0, y is -4. But it can't cross an asymptote, so that point's no valid. It's no good. This point is no good.
Approach 0. How come it worked out? How come that
Maybe luck of the draw. Okay. All right. So now we need to do y-intercepts. I can factor this into x plus 2, x minus 2, right? So that's going to cross here and 1, 2 here. So this one crosses. And the funny thing is, I think it does a little blip like that. This one here gets close but never crosses. Now we need to figure out what happens in this middle section. It doesn't cross here, correct? So it's probably up here. It's probably going to look like this. But just to prove it, what do I need to do? Plug in a point. Yes?
Why do we not use the denominator on that one?
The y-intercept.
Why do we not use the denominator for what?
Whenever you got x plus 2 and x minus 2.
Okay, so I went through that too fast. Okay, x squared minus 4 has to equal 0 over your denominator, right? I'm going to multiply both sides by the denominator. It's going to go away. 0 times the denominator goes away. Okay? All right, so now let's prove that I drew it right. How do we do that?
Well, do we know there's a line up there yet?
How do we know this is up here? It probably goes closer down to here. It probably goes something like this. That's my guess. It doesn't cross the asymptote, right? We already found where it crosses. It crosses here. We need to plug in a point between 0 and -1. Yeah, so r of -1/2 equals -1/2 squared minus 4 over 2 times -1/2 squared plus 2 times -1/2. -1/2 squared is 1/4 minus 4, 3 3/4 over 1/2 squared, 1/4 times 2 is 1/2. Those 2's cancel, right? Minus 1 equals 3 3/4 divided by -1/2. Maybe I should change that. 3 3/4 is 15/4 divided by -1/2. I drew it wrong then. 15/4 times -2 over 1. So this is negative. So I drew it wrong. -30 over 4. It's a negative number, whatever it is.
So,
Oh, is that right?
you can simplify that.
Did I make a mistake? Because I could have sworn. I'm looking here, it says I drew it there because I was cheating. I'm looking here. What did I do wrong here? Negative 1/2 squared is positive 1/4 minus 4. Oh, this is negative. You guys aren't checking my signs. What are you doing? Negative over negative makes that a positive number, just like I said.
I'll just say something.
How come you guys can't check my signs? Come on.
Andrew is saying the whole thing. You should say it loud enough. Still waking up.
Yeah. No whispering. All right. Ready for another? We might only get through one section today. How does that make you feel?
Good, huh?
Well, you quiz on one section, right? Do we need to get through one?
Oh, we got lots more here. Maybe I should start moving ahead to the fun stuff.
Oh, Professor, don't do that to us. You can't even get your science correct.
All right.
Very good.
Okay, let's do a good one here. This will be a fun one. S of x equals x minus 3 over x squared minus 3x. Okay. Whose turn is it now? Berkeley, you're awake now. It must be your turn.
Okay.
What do we do first? Well, I haven't picked on Angel either. You guys over here by yourselves. And did I pick you? Oh, I forgot.
So would you put 0 in the denominator?
So you're checking your vertical asymptotes. So that factors into
Oh, x.
yeah, pull out the x. And you're left with
Plus 2 or minus.
you and I both need to go to bed earlier.
Yeah.
Okay, so your vertical asymptotes are where? X equals 3 or 0. Okay, let's do it. 0, 1, 2, 3. Okay, now what? Well, I lost my focus there, just like a lot of you.
Ooh, shots fired. They're coming back.
Okay, do you know the next step? Do you want to tag?
I want to work through it, but I will tag.
Do you know what the next step is? So we're looking for our horizontal and our obliques, right? Okay. One of these days we're going to get an oblique in here. Okay. So now what? You're going to tag Angel?
So the degree is 1 on top, 2 on the bottom, and since it's bigger on the bottom, y equals equal, or 9 equals to 0. It's on 0.
So you're going to asymptote at y equals 0, okay?
Plug that in, and it does not. Or as you said, the equation equals 0.
And then we need to see if it crosses, so we're setting it equal to 0, x minus 3 over x squared minus 3x, okay? That's going to go away, x equals 3. Now, we got a problem here, right? You see the problem? It crosses both the x and the y, and I said you can never cross a vertical asymptote.
So then we can't do it.
So what does that mean? That's a new thing that I didn't add, so you might want to add this here. Also, notice something interesting. The same factor is on the numerator as on the denominator. You see that? Anytime you see that, it means you got a hole in your graph.
What the
black hole.
Wait, what? Can you repeat those last two sentences?
Okay. See, it was a good thing we gave this one to Angel, right? So we've got the same factor on top and bottom. That's a clue that you're going to have a hole in your graph. Okay? Remember, I said under no circumstances will you ever cross a vertical asymptote. This says, oh, you're supposed to cross the horizontal, but it's the same place as the vertical, and you can't cross. Okay? So because you can't cross, you've got a hole at 3.
How exciting.
Yeah.
Lovely.
Should have added that one on the thing there, right?
Wait, why is it right there?
So,
anytime you have the same factor in the top and the bottom, means you're gonna have a hole.
Yeah, but, so the one we just saw, the one that I with, so it's 3 is equal to x right here. So isn't the 3 that x found?
Oh, you're talking about here. Yeah, the problem is, I said you can never cross. You've got x equals 3, but I said x cannot equal 3.
Yeah.
So that's the problem. Okay?
So the original function is x minus 3 over x squared minus 3x.
Correct.
Should we not simplify the fraction before?
You should not simplify it before, because if you do, if you did simplify that, you'd be left with 1 over x, right?
Yeah.
And then you would miss your hole.
Okay. But I mean, if we had it where it was like 2 on top and bottom,
Right.
and we could factor up to 2, and we can do that as well.
Say it again.
So if you multiply the top and bottom by 2, theoretically, for a new problem, or a number.
2
we
times
could
x minus
simplify it.
3 over 2 times x squared minus 3x.
Right, and then just assume that's the original problem that it's multiplied in. Could we not pull out the 2 and simplify?
Well, either way, you can still look at this as your leading terms here, right? You'll have 2x over 2x squared, which simplifies to 1 over x, which is going to go to 0.
I guess I'm just confused with why I wouldn't reduce the fraction before I try to graph the.
Why? Because you're not supposed to. Because
I'm having a
that's,
hard time wrapping my head around that.
this is what they gave you. You still need to use that fraction. And by simplifying it the way you want to do it and making it 1 over x, you're losing information.
Will there ever be a situation where we have to do this, but you have to do that from a non-factor or non-simplified, just like this crazy function that will always be like neat for us? I think that's.
Will it always be neat for you? I don't know.
Like, I get like.
I doubt it. But yeah, the clue is here. This is important because the problem is if you cancel that out, you lose your x cannot equal 3 in your domain. So you lose information when you cancel that. And so you have to stick with the whole fraction. It would be nice, but don't do it.
But it could equal 3, because if you plugged in a 3, at the top you'd have 3 minus 3, you'd have 0 divided by 0, which you can't do.
0 divided by 0?
Can't you? Divide 0 by 0?
Can never divide by 0.
Even by 0?
Under any, even by 0.
Okay, that makes more sense.
Okay. All right, so now, and we're not going to have any intercepts because we got an asymptote on both of our axes, right? So there's no sense finding intercepts. So I know I've got a hole. Okay, so I need to pick something in this region, and this region, because I'm not quite sure what goes on. So what do we do? Now you're just going to have to pick points. How about S of 4? 4 minus 3 over 4 squared minus 3 times 4 equals 1 over 16 minus 12 is 4, 1/4. Okay? So at 4, I'm at 1/4. So I'm about right here. Let's pick another point. Let's pick S of 2. Okay, 2's in this region. S of 2 is 2 minus 3 over 2 squared minus 3 times 2. Negative 1 over 4 minus 6 is negative 2. So that's positive Did I do that right? Yeah. Positive 1/2. 2 is positive, is that right? Oh, this one's really funky. Oh. Am I looking at the wrong one? Well, they didn't graph that one, we just have to do it ourselves. Okay. Did I do that right? 2, 1/2? It doesn't seem right to me. Let's do S of 1, just to be sure. 1 minus 3 over 1 squared. Sorry, yeah, minus 3 times 1. Negative 2 over 1 minus 3 is negative 2, so that's 1. Okay, so we're good. So this one apparently goes something like, I want to do S of 5 just to make sure. 5 minus 3 over 5 squared minus 3 times 5. Plus 2 over 25 minus 15 is 10, 1/5. So this is at 1/5. So that's it. So here. Oh, this one's just funky. I want to go like that. Okay. Then over here, we need S of minus 1. And I feel confident that this one's going to be easy. Negative 1 minus 3, negative 1 squared minus 3 times negative 1 equals negative 4 over 1 squared is 1, plus 4 is 5, negative 4/5. So this one's going to go something like that. That was a good one. I'll have to make that a test question.
Is it gonna be a quiz question?
Or a quiz, well, it's a quiz and test question. That's good. Okay. Let's do another one. Shoot. Here, I'm going to summarize because I didn't even get to a slant one, did I? No, slants are easy, but let me just summarize because we only got 5 minutes left. So let me just do a quick summary. I'm not going to go through all the steps, but I do want to highlight a couple of interesting things here. S of x equals x squared minus 4x minus 5 over x minus 3. Okay? I'm going to concentrate mainly on, because I think you got the verticals down here. You can see the degree of the numerator is greater than the degree of the denominator, correct? Okay? So I know that I'm going to have a vertical asymptote at 3, and y equals x squared over x, which equals x. Do you see that? So therefore, this is what we call an oblique asymptote. Okay? So in this case, I'm going to cheat because we're out of time. And this one's going to look like this and this. Okay? So that's something you could see. The other thing that I want to point out here that's a tricky one is this one here. F of x equals x cubed minus 2x squared over x minus 2. Okay? Now, you can factor the numerator. This is going to be x squared times x minus 2. Okay? You see the same factor in both places, correct? Okay? I know that x cannot equal negative 2, 1, 2. I also know that I've got what kind of an asymptote there? Parabolic. Wow. Okay? And so I've got a parabolic asymptote that looks like this. Okay? Now, because I'm cheating here, they didn't finish drawing it. But they do have a hole right here in your graph. I thought they would finish this. Did they not finish it? Okay, so this is another one where you've got a hole where these are. And basically just pick points on either side, and then I believe it goes something like this. I don't know, something like that. I'd have to pick some points to grab. But at any rate, those are the last tricky ones, I think.
Good.
Okay. So quiz tomorrow is only on one section, but it was a big section and there's a lot of homework. It's like 2. So 3.6 quiz tomorrow. See you all tomorrow.
I would like to make a case on my exam.
Okay. Let me turn this off.
Okay.